Okay, continuing on with chapter 3. These chapter 3 slides that I made. Again, in this textbook by author last name Malik, the 8th edition of a C++ textbook. If you would like to not use the entire namespace standard, you can say using standard cout, using standard end line, using standard string. Strings are common. String, I think, maybe is included somewhere in IOStream or something else, something that IOStream includes, like yVals core iStream includes string at some point. We'll just see if that generates an error. You can set these things up here. Now, if we want to print that greeting, which is this thing called a string, which is an example of something called a class that we'll talk about in programming fundamentals 2, talk about later. Don't forget a semicolon. If I don't put that semicolon, we hover with the mouse and we say expected a semicolon, show potential fixes, add semicolon at the end of previous token. So this line number 12 is being referred to as a token, or at least the last part of line 12. This thing called a string literal. Okay, so if we run this program, do we see hello? Yes. Okay. So this is an alternative to this. I did talk about macros as well. Macros are extremely common in these. If I go to view and solution explorer and look at external dependencies, I click this little arrow. These are all of the files that are brought in whenever you #include IOStream. So they're alphabetized. Let's see. If we look at output stream, we see #define, OStream. These things called macros are very common in C and C++. So if we would, for some reason, we don't like cout, we can say #define print, and we pass it something called text. Now we have defined a macro. This gives you some idea of why this is called a macro. This is a fair bit of text. Maybe for some reason we wanted to print it twice. Maybe we now call this print 2x, something like this. Should we put this on different lines? It looks like there's something funny going on there. So maybe macros should only be one line. Yeah, I'm getting into the weeds a bit. Let's put a semicolon there. And you notice that print 2x has got this an interesting symbol here. It's the symbol for a macro, a #define. Here's another macro, #define CRT. C runtime, I think, is what this means. It doesn't mean cathode ray tube, if I recall correctly. Anywho, just on the subject of further macros, if we scroll through this list in the standard namespace, we're likely to see that macro symbol pop up again. Well, we haven't yet, which is pretty interesting. I might be mistaken about that. Anywho, if we, I was going to try to make the point that this is a bunch of text and this is a relatively small amount of text. So micro, macro. Micro means small in science, macro means large generally. So a large amount of text has been replaced by a small amount of text, which is, I believe, part of the reason why they call this a macro. Okay. Test. Oops, not define test, but rather print 2x test. So print 2x, and this is this macro that I've defined. It's been defined in source.cpp, which is this folder, this file right here, print 2x, and there's no error here. If we run this, we can see test. So that is the result of this state, these two lines of code. So these things called macros. A macro definition can be convenient occasionally. If you insist on defining a function called print rather than using cout, I suppose that's fine. Okay. There is an option in Visual Studio and in C++ in general to do something called pre-compiling headers. Let me just show the content of this slide really briefly. Pre-compiled headers can be good to speed up the execution of a program if you're working on a large project, but you can pause the video and look at those instructions in detail if you like. But in the class that I'm teaching, that's probably not so necessary. So I'll just skip over that content. But it's a very good thing to know about for people who anticipate going into C++ in a deep way in the future. Okay, but let's talk about predefined functions in programming. Functions in algebra, something like f of x equal x squared is the example with which we are probably most familiar. If we bring up a Windows calculator, we could graph this function. We could say graphing and then enter x. Shift 6, you can see the keys I'm typing, x, shift. The caret operator, it's shift 6 on a typical keyboard. If we plot x squared, we see this function. If we plot sine of x, we see another lovely function. So these are functions from algebra, and we are familiar with these things. Most of us have taken algebra. Functions in computer science are fairly similar, generally speaking. There's the square root function, and it is defined in this file called correct_math.h. C file, not a C++ file. I'm pretty sure of that. So let's print the square root of 25. This is, so square root is what we might call a predefined function, or also built in. It's built into the standard library in C++. Or at least it's referred to in this IO stream. And when we say standard library in C++, this is meaning that whenever you download Visual Studio or CLion, so CLion is a cute name for another thing called an integrated development environment, or if you install a compiler called the GCC compiler, or this thing called the MinGW. I can't remember how to spell it. If you install these things, and the compiler comes with these header files generally, so it's a standard library. But that's what I mean by predefined or built in. So it comes standard, and you should expect it to, because square root is a common operation, at least in math and physics, and business maybe not so much. But other functions, the PAL function, PAL of 2, 4, we can see how this acts. This will make two different lines of output. So we see 5 and 16. So 5 is the square root of 25. 16 is 2 raised to the 4th power, 2 raised to the 4th. We cannot use this caret operator is what some people call this. We do not get the expected output if you do this. In fact, there's an interesting error here. And we need to put this in parentheses for reasons that I won't go into. 2 raised to the power of 4 is certainly not 6. 2 times 2 times 2 times 2 is 4 times 4, which is 16. So it's not 6. This is, I think, the bitwise XOR. Yeah, let's take a look once again in the Windows calculator. If we go to not standard or scientific, but programmer mode, and we'll stick in decimal here. We won't switch to hexadecimal. With hexadecimal, you notice A through F option. These quote numbers become available. In binary, you only have 0 and 1. You have parentheses and other operators like the mod operator, modulus. Let's stick in decimal and say 2. And the caret key is actually not being displayed on this calculator, but I can hit shift 6 and 4. And let's see. 2. Maybe I'm misremembering. Let's just use the internet to display what I'm talking about. To an XOR calculator. Let's see, what did we get? We got 6. And the input, let's make it decimal 2, and let's make input number 2 also decimal. I think that's how this is being interpreted. 2 XOR 4, and the output in hexadecimal is 6. So evidently this is being, it seems that this is being displayed in hexadecimal. In the class called computer organization or computer architecture at some universities, this is XOR. The XOR operation is gone into in great detail, so I won't go into details about how this is calculated at the moment. Okay. A point here is just to be careful because this caret is not operating the way we're used to. Similarly, if you type 2x4, this is not 2 times 4, 8. Okay. Some additional functions. There's the sine function. Sine, you have to be careful of whether radians or degrees are used here. But let's see, sine of 90 degrees. That is 1. And will this get output as 1? No, so that's in radians, but let's type sine of 0. It should be 0 regardless of whether it's degrees or radians. If we type cosine of 0 degrees or radians, that's 1. And we could verify that by plotting that function cosine of x. And maybe get rid of these 2 so we're not distracted. And cosine at 1 is, or cosine of 0 is 1 right there. So those are a few built-in functions, mathy functions. There's an absolute value function. These purple cubes all mean functions. There's a function called address of, which we'll not get into for now. All of these purple cubes mean these are functions. And arctangent, h, hyperbolic, I'm not sure, float and long. You see F and L, these are the return types. Many functions, and we're not going to get into half of them or even half of them that are built into the standard namespaces. The number of arguments matters. If you attempt to supply a second argument to the cosine function, this doesn't make any sense. And again, these things are called arguments. Args is sometimes used by programmers as a shorthand, a quick way of saying it. We don't have to just print these these values. We could also store this. We could say double 5 equals square root of 25. And then we could see out that value 5. It's quite the well-named variable. We don't have to print it, but that was that 5 that got displayed at the end here. So it displays 5, 1, and 5. The variable named 5, whose value is assigned to 5. If we pass in illegal values, not illegal, but we'll see if we pass in what I would call interesting values. Here we see negative, not a number, NaN, and IND means index. So we want to be careful of cases like this. You might think that it should print I, the imaginary number. But in this case, C++ doesn't have this interpretation. There are certain programming languages and libraries that are built into languages that might handle that more gracefully. Okay.